So this week we're going to look at section 2.2. What we'll do is we're going to break it into 3 parts. So we won't get a review day this week, but we will, have at least, it'll be pretty slow paced going through it. So we'll do part 1 today. Part 2 will be on Wednesday. Part 3 will be Thursday. I will be after school on Thursday if anybody needs to come by to make anything up. Okay, so what is unit circle trig? Let's take a look at it. So first thing to kind of look at is just title. And everything we do this week is going to have to do with a circle, specifically what's called a unit circle. All that a unit circle is a circle with a radius of 1. I think we've written that before, but it's where the radius equals 1. And the reason why we do it on a circle with a radius of 1 is because that makes the formulas as simple as they could be. We can do it on a circle that has a bigger radius or smaller, but it makes the formulas a little bit more complicated. All right, so what I've drawn here is a circle. I've drawn an XY axis going right through the middle. And remember, as you go around the circle, 0 is on the right, 90 is at the top, 180 is at the bottom, 180 is on the left, and 270 is at the bottom. All right, so let's think of an angle. Grady, could you give me any angle you want?
90 degrees.
90 degrees. Okay, so I'm going to draw a 90-degree angle. Could have given me anything, but he gave me 90. So that's my first side. Does anybody remember what we call that side of the angle? Like the side that it starts at? Begins with an I. Give you a hint. It ends with the terminal side. So terminal is where it ends. Initial. Yep. So when we draw an angle, you always put the initial side on the positive x-axis pointing to the right. And here's my terminal side. Now, when you draw your terminal side, it hits the edge of the circle right there. And no matter what size angle you drew, the terminal side, if you extend it far enough, would hit the circle somewhere. The goal is to figure out what is the coordinate where it hits the circle. So if I made this angle bigger, like let's say we make it 135, now the terminal side would be more over there, and it would hit right there. That's the whole goal, to figure out where the terminal side hits the circle. Right, and let me write that down. Now, Grady said 90. Okay, so that was a good one. That's one that we could do. If he said something like 14 and a half, well, I could estimate what a 14 and a half angle would look like. And I could draw it in. But I would not have an easy way to find that coordinate. We're going to focus on angles that are multiples of 30 and 60 to find the coordinate on the unit circle. And 90 is a multiple of 30. So that is one we can do. So angles that are multiples of 30 and 60, we can find the coordinate for it on the unit circle. And so we're going to be looking at angles like 30. Actually, what else I could add something to that? 30, 60, and 45. As long as it's a multiple of 30, 60, or 45. So multiples of 30, that would be numbers like 30, 60, 90, 120, 150, 180, 210, so. Multiples of 45 would be numbers like 45, well 90, but we already said that. 135, that's 45 times 3. 180, 225, 270, and 315. And there's some overlap, like 90 is a multiple of both 30 and 45. So let's go back up and see if we can figure out the coordinate for 90. There's 4 angles I think you're going to be able to find the coordinate for without me really showing you anything. So let's go back up and let's look at 90. This point, that's the origin. That's where the x and y axis cross. So that's 0, 0. And what's the size of the circle that I said we're working on? What's the radius of it? 1. So to get to 90, you don't go left and right at all. All you do is go straight up until you hit the edge of the circle. Well, how far is it from here up to there? It's 1 unit, because that's also the radius. 1 unit in every direction. So what do you think the coordinate is to get to 90 degrees? Yep.
0.
Yep, 0, 1. And that is always the coordinate for 90 degrees. That never changes. The x is 0, the y is 1. Let's do this one. So this is the coordinate for 0 degrees. Okay, we're gonna do 4 of them. Anyone think they know what the coordinate for 0 degrees would be? Yep.
1, 0.
Yep, 1, 0. The 4 coordinates we're doing all have zeros, ones, and negative ones. They're the 4 easiest coordinates to do. All right. How about the coordinate that represents 180 degrees? Yeah.
1, 0.
That's negative 1, 0. Yep. And the coordinate that represents 270. Yeah.
0, negative 1.
Perfect. 0, negative 1. So those are our first 4 coordinates on the unit circle. For 0, 90, 180, and 270. Every other coordinate we do, both of these are going to be numbers that are not 0. Like when we do a 45-degree angle, it's going to be right about there. And neither number has a 0. When we do a 30, right about there. And 60, right about there. So by the end of the week, we're going to learn how to do 3 points in every quadrant and 4 points that are on the axis. So you'll know how to find the coordinates for 16 different points. But those are the first 4 we're going to do. 0, 90, 180, 270. Okay, so a couple things that might help us, and this might be something we've already done, but might help us if we get an angle that's too big to visualize where it would be on the circle. When we talk about angles, there's positive angles, and then there's negative angles. The only difference between positive and negative has to do with the direction you rotate to get to. If you rotate in a counterclockwise direction, those are positive. And let me show you. So in the lower right, you can see there's degrees, and the bottom is radians. And as I rotate counterclockwise, it shows me what the angle would be. It's positive. If I rotate the other way, okay, if I go clockwise instead of counterclockwise, clockwise is going to give me a negative angle. So here's clockwise. And you can see the angle's negative. Now for me, it's easier to visualize certain types of angles. Do you think in general it's easier to think about where positive angles are or negative angles? Positive. It's always easier to work with a number that's positive. But we don't want it to be so positive that it's like that. Because if you said to me 1215 degrees off the top of my head, I would know that that's exactly where it is. But there's something that we can add and subtract from that number to give us a smaller version of it. And it won't mess up our answer. 1215 is exactly the same as 855. And that's exactly the same as 495. And that's the same as 135. When I go around like that and bring it back one rotation, how much is one rotation?
360.
360. So if you have an angle and you add 360 or you subtract 360, it doesn't change the coordinate of where you stopped. Here's another example. Here's 90 degrees. What did we say the coordinate of 90 degrees is on a unit circle? 0, 1. So now let me go like this. 450. What's the coordinate of that red circle now?
0.
It's still 0, 1. So adding and subtracting 360 to a number doesn't change where it would stop in the circle. The idea is if you give me something that's too big to think about, let's say you give me an angle like, bring out my calculator. Let's take 2,500 degrees. That's so big, you've gone around too many times. I'm not sure where that would stop. But I minus 360. And just keep doing that. Each time I minus 360, it's bringing it back one revolution, making it easier to think about. 340. That I can visualize a lot easier than 2,500. I know 360 is all the way around. So 340 is a little bit before going all the way around. So if you've got an angle that's too big, you can subtract 360 as many times as you need to. But don't subtract it so many times that you turn it into a negative. The goal is always to work with something between 0 and 360. That's the easiest angles to work with. It's not too big, not too small. Right between 0 and 360. All right, so we can make angles smaller by subtracting 360. But what if we had an angle that was like negative 1,500? What could I do to that to make it bigger, but it wouldn't affect the coordinate? Yeah, I can add 360. All you're doing is adding one revolution. That brings you exactly back to where you started. It just makes it so it's not a negative number. So same idea here. To make it, bless you, to make a negative angle positive, just keep adding 360 until you get an answer between 0 and 360. But don't go over 360. Then you're going to be making it too big. And another thing that might come up here is you may be given something in radians. I think for most people, they're probably going to want to change it to degrees. So if you don't remember how to do that from last week, we'll talk about it. Okay, so what we're going to look at is the definitions of the 6 trig functions that we use in there. This will be the first time we've seen them in this class, but each definition is going to be based off of 2 letters, an x and a y. And that's the x and the y from a coordinate that you have to find. Does anybody know, like, one of the 6 trig functions? There's buttons for them on the calculator. But you want to think they know one of the 6? Yeah.
Sine.
Sine. Yep, that's one. Yeah.
Cos.
Do you know what that one is? Cosine. So sine, cosine, yeah. And tangent. Those are the 3 most common ones. Those are the 3 you have buttons for. The other 3, cosecant, secant, and cotangent, you don't have buttons for on the calculator. Okay, so let's take a look at this. So we're going to write down the definitions of those 6 trig functions. 3 of them you guys said, or the 3 I said. And they're all going to be based off of a coordinate. So if you can't figure out the coordinate in a problem, you are pretty much stuck. You're not going to be able to do unit circle trig. You have to figure out that coordinate. And for 0, 90, 180, and 270, we already did them. So you could just put those on a reference sheet so you have them for the test on Friday. Okay, for each trig function, I will write it out the long way, but most of the time we use a 3-letter abbreviation for it. So from now on, I'm just going to write 3 letters. The first trig function is sine, abbreviated SIN. The next one is cosine. That's abbreviated COS. And the third one is tangent. And that's abbreviated TAN. Yes.
I just need you to spell
I do. And what I'm going to do is I'm going to put an equal sign after each one of them, and I'll put the formula next to how you find it. So sine, cosine, and tangent, those are what we call functions. The other way you can do something with a function is if somebody tells you a number to plug into it. Like if you just said to me, find the sine, I'd be like, sine of what? What do you want to know the sine of? It's like if you just said to someone, find the square root. Well, you got to tell the person the square root number you want to use. So with sine, you would see something like this. That means find the sine of 90 degrees. Just like this means take the square root of 25. That's the number you're plugging into the formula. Well, square root, we know how to do that. You're looking for a number times itself that gives you 25. Here, I'm going to tell you what you have to do to find the sine right now. Well, the first step is going to be to find the coordinate. Once you know the coordinate, the sine is the y value. Well, let's try it. Let's think about 90 degrees again. What was the y value for the coordinate for 90 degrees? 1. So when I hit enter, I get 1. That's why, because 1 was the y value. Now cosine, that's the x value of the coordinate for the angle that you're looking for. So think of 90 degrees. Think about where it is. What was the x value for 90 degrees? Yep, 0. It was 0. That's why when I hit enter, I get 0. And the tangent, that's our first trig function that uses both. It uses y and it uses x. And you divide y over x. Now, the next 3 trig functions, I want you to put them across. Hopefully you have some room. But I want them across for a certain reason. I'll show you why in a second. So the one that I put across from sine is called the cosecant. And all trig functions have three-letter abbreviation. It's usually the first three letters when you spell it out. But for cosecant, how come we don't use the first three letters?
Is the same as cosine?
Yeah, we already used them. So instead of using the first three letters, they use the syllables. Co, C. That's CSC. The one I put across from cosine is secant. That's SEC. And the one across from tangent is cotangent, and the abbreviation is COT. And they're all just different functions. It's kind of like saying you have different roots, like a square root, a cube root, a fourth root, a fifth root. They're all just different kinds of roots. These are all just different kinds of trig functions. And the connection between the one on the left and the one on the right is you flip one to get the other. Well, y isn't a fraction, but you could think of it as a fraction, because you can always put one number in the bottom if something's not a fraction. Yeah, you can always just put it over 1. And that's how you could think of sine as a fraction. So if you flip sine, and that gives you the cosecant, what do you think the definition is for cosecant?
1 over y.
It's 1 over 1. So to find the cosecant of something, you take the y value and you flip it. Same idea for secant. Anyone think they know what the secant is?
Is it 1 over x?
It's 1 over x. That's why I put them across from each other the way I did. So if you want to know the secant of an angle, you take the x value and you flip it. And how about cotangent? That's going to be x over y. Yep. And the four angles we talked about so far are 0, 90, 180, and 270. Those four angles are all on the xy axis. And the xy axis divide the coordinate plane into 4 quadrants. That's why we call these angles the quadrantal angles. Okay, so just to be clear about that, 0, 90, 180, and 270 are not in quadrants. They're on the axis. And for today, these are the only ones that I would ask you to figure out the coordinate for. Tomorrow, we're going to study more about how do you do 30 and 60 and 45. But for today, when we get to it eventually, you're going to have a problem like this. We basically already did it. But find the sine of 90. Find the cosine of 90. So we'll work our way through that. Alright, so how do you do unit circle trig, right? We know it depends on finding the coordinate. That's the whole key behind it. But there's really 2 things you have to do. Finding the coordinate is step 1. You have to find a coordinate that represents the angle. So we know for 90, it's 0, 1. 180, negative 1, 0. You've got to find that coordinate first. And notice the last thing I wrote in parentheses. Sometimes you are given a point. So if they give you a point, then you don't have to do anything to find it. It's given automatically. Once you know your point, you're going to know an x and you're going to know a y. You're going to have those 2 numbers. You're going to take those 2 numbers and you're going to fill them in to all 6 of these formulas. Now, if the problem only asks you to find cosine, then fine, you only have to do a cosine. But we're going to practice all six. So step 1, find your coordinate. Step 2, use your coordinate that you just found in step 1 and plug them into the definitions on the other page, the previous page. Generally on the test, you are only going to have to find one trig function per problem. You're not going to have to do sine, cosine, tangent, secant, cosecant, and cotangent, all in the same problem. But for us in class, we will practice all six. Everybody have those 2 steps? So what I'll do, I'll leave those up while we do the first problem, and then I'll make the first problem bigger in a little bit. So in this case, they are giving us the coordinate. They're telling us the coordinate is -1/2, comma √3/2. Does that look like the coordinate for 0, 90, 180, or 270? What do you think? Does it look like any of those? Chris? No. That's because it's not. That is not the coordinate for 0, 90, 180, or 270. What is it the coordinate for? Don't worry. You don't need to know. Tomorrow you'll know. But for today, you don't need to know what angle is represented by that coordinate. I'll give you a hint. It's in quadrant 2 because you're going left and then you're going up. But you don't need to know what angle that represents. All you need is a point, and you have it. So that point represents some angle, which we're just going to call theta. We don't know what it is. If you've done unit circle trig, you know what it is. If you haven't, then you don't. We're going to find the 6 trig functions of the angle that's represented by that location right there. Let's just make sure we know which number is which there. What number is my x value there? Yeah?
-1/2.
So that's x, and that means √3/2 is my y. So notice what's in the y value? A square root. When we started trig last week, I talked a little bit about square roots, and like we can't leave square roots in the bottom of a fraction. That was one thing. We have to simplify square roots. That's why we talked about square roots the first week, because they're going to come up right here. So 2 things we have to remember. 1, don't leave them in the bottom of a fraction. So if you get something like this, you need to fix it by multiplying top and bottom by the square root. So you multiply the top and the bottom by the square root of 3. And in the top, there's not really much you can do. It's just 2 square roots of 3. But what about the bottom? What's the square root of 3 times the square root of 3? Yeah? Exactly. So can you get rid of the square root? No. But can you move it from the bottom to the top? Yes. And that's what you always do when you work with square roots. For whatever reason, somebody decided it was better to have square roots in the top than in the bottom. That's what we do. All right, let's try an example, and that's going to pop up in, actually that exact problem is going to come up in this one. All right, so let's start with the sine. Kiana, what is the definition of sine? Yeah, it's the y value. And what's the y value in this case? Yes. Good. And that's all you have to do for the sine. It's the y value, and look at the y value in your coordinate, and write that in. Sine and cosine are the easiest. Let's do cosine. Austin, what's my formula for cosine? Curse. It's the x. Cosine is equal to x. And how about Tony? What's my x value in this one? What's that? The cosine. I don't think my x value is 2 in this case. Yeah?
Would it be negative 1 over 2?
Negative 1 over 2. So cosine is your x. And in this problem, x is negative 1/2. So those two you can get just by looking at the coordinate. There's no arithmetic or anything you need to do. Okay, let's look at tangent. Cameron, what's my formula for tangent? Yep, y over x. Y is root 3 over 2. So I'm going to do that off to the side because I'm going to have to simplify it. So there's y. And x is negative 1/2. So we have to divide a fraction by a fraction. What's going to happen? The 2's are going to cancel. Because when you divide two fractions, the way you're supposed to do it is take the one that's in the bottom, flip it, and multiply. Well, if you take what's in the bottom and you flip it and you multiply, the 2's are going to cancel. Not the negative. That's still there. So when you divide these two, what you're going to end up with is negative square root of 3 over 1. So it's just negative square root of 3. The other thing you might have noticed, but we don't use any decimals. Okay, when we're doing this out, you don't type any of these in and write decimals. So that's our tangent. So once we get the first three, the last three, all we have to do is do something to each one of the first ones we had. Does anybody remember what we said earlier? To get this one, what do you do to the sign? Yeah?
Flip it.
You flip it. That's all you have to do. Just flip it. Ryan, what do I get when I flip the sign?
2 over the square root of 3.
Okay, so that's a good start. You get 2 over the square root of 3. But what's wrong that we can't leave it like that? Yeah.
And then square root of the bottom.
Right, we can't have the square root in the bottom, and I just went through how to fix that exact problem. You multiply the top and the bottom by square root of 3, and then you go straight across. 2 times the square root of 3 in the top. Square root of 3 times square root of 3 is square root of 9, but we could just write 3. So this is 2 square root of 3 over 3. And my cotangent. Sam, which trig function do we flip to get the cotangent?
You flip the tangent.
Flip the tangent. Now right now I don't even have a fraction for the tangent. So how could I make tangent a fraction?
Put 1 under it.
Yep, you can put a 1 under it. So when you flip that, you don't have to fix it, but just tell me what you get when you flip it.
Just negative 3. Negative square root of 3.
Well, we have the square root of, negative square root of 3 right now. So that's what we're starting with. But we have to flip that.
Just 1 over negative square root.
Yeah, you could say 1 over negative square root of 3. It does, when you flip it, it doesn't matter where you put the negative. I usually keep the negative in the top. As long as you keep it negative.
Then you do the problem.
What's that?
You have to do the problem.
Yeah, now we have to fix that so we don't have the square root in the bottom. How about, Fira, how would I fix that? Or what would I multiply by to fix that? Yep. So multiply by square root of 3 over square root of 3. Have to multiply the top and the bottom by the same thing. Okay, now we go straight across. Jenna, what's negative 1 times the square root of 3?
Negative 1 square root of 3.
Yeah, so it's just negative 1 square root of 3. We could really just say negative square root of 3. If you want to put negative 1 square root of 3, that's fine. And what about in the bottom? Tyler, what's the square root of 3 times the square root of 3? It's what did you say? Yeah, just 3, right? The square root of 3 times the square root of 3 is the square root of, multiply these two numbers together, square root of 9. But that's just 3. So there are your 6 trig functions for some angle, which we don't know, but that is the location of the angle. If you really want to know what that angle is, it's 120 degrees. That's the coordinate for 120 degrees. Yeah. We'll talk about that. Okay. Any questions on how we got those 6 trig functions? Now, I'm going to give you another coordinate. First of all, does that coordinate look like the coordinate for the 0, 90, 180, or 270? Does it look like any of them? No, it's not. But look at the x value and look at the y value. How do the x and the y compare to each other in that coordinate? They're the same. So, does anybody know what angle that would represent if you were on the circle and you went right and you went up the same amount? Yeah?
45.
It is. That's the coordinate for a 45-degree angle. You do not have to know that today. But root 2 over 2, root 2 over 2 is a 45. All right, but the important thing is we have the location of the coordinate. We have the x and we have the y. So we're going to do the same thing we did before. Find the 6 trig functions using that x and that y. Let's start with sine. Nyasha, what is my formula for sine?
Is
We're looking for a single letter.
so it's gonna be the square root of 2 over 2.
Yes, what's the letter then? Because they're both square root of 2 over 2. This one, you could mix up the x and the y this time and you'd get lucky, you'd still get it right. But we do have to know which one.
The y.
This is the y. Yeah. So the sine is the y, which in this case is root 2 over 2. Jackson, what's my formula for cosine?
Oh, it's the same thing.
And because it's which letter?
Because it's X.
Because it's x. Just a coincidence that they're the same this time. But x is the same. Okay. Let's see, Austin, what's my formula for tangent?
Negative square root of 3 over 3.
So I'm looking for letters. I'm just looking for the letters we're going to use to figure out tangent. So x is part of it. Y is part of it. And we got to do something with the two of them.
Multiply.
Back to it. So tangent is when we divide. Okay, so y divided by x. Now, you might think, well, that's kind of complicated because you're going to have all these square roots everywhere. But we're going to divide y by x, and y and x are the same. So what do we get? We just get 1. Okay, so now we've got the 3 that are on the left. What do we do to each one of them to get the 3 that are on the right? Flip them. Take each one and flip them. Let's start with cotangent just because I think that's the easiest one. If you flip 1, what do you get? 1. There's 2 numbers you can flip and they stay the same. 1 is one of those numbers. So if you flip 1, you get 1. And the other nice thing here is because sine and cosine are the same, cosecant and secant are going to be the same. So we just have to figure out one of them and then we know both. All right, so let's start by flipping the sign. Talk about, Abigail, what do I get when I flip my sign?
2 over square root of 2.
Okay, we get 2 over square root of 2. And Dominic, what do I need to do with that so we can fix it?
Negative 12. 2 multiplied by the square root of 2. Both of them.
Over what?
Over square root of 2.
Yep, I'm going to multiply by square root of 2 over 2, and now we're just going to go straight across. 2 times the square root of 2, you can't do anything with that. Just 2 times the square root of 2. What about in the bottom? What's the square root of 2 times the square root of 2? Yep.
2.
That's the square root of 4, which is just 2. And look what just happened. We had a 2 in the top and a 2 in the bottom, both outside the square root. You can't cancel inside. But you can cancel outside. So all we end up with is square root of 2. So what does that mean my secant is going to be? It's also going to be square root of 2. And those are the 6 trig functions, really for the coordinate 45 degrees, but you don't need to know that. It's the coordinate root 2 over 2, comma root 2 over 2. Any question on it? Let's try this one. Now, a little different. First of all, the directions are different. It's only asking for the sine, the cosine, and the tangent. And the information they give you is different. What haven't they given me this time that I need to do this problem? They have not given me a coordinate. Instead, they've given me the angle. But I don't want the angle. I want the coordinate of that angle. So they gave me 3 pi. There's 2 different units we can use to measure angles. What are the 2 ways? Radians is 1. And the other one? Degrees. Which one is that? 3 pi. That's radians. We know it's radians because there isn't a circle above it. Now, I don't know about you, but I think it's easier to figure this out if it was a degree problem rather than a radian problem. So let's take this and change it to degrees and then hope that we can figure out the coordinate on the circle. If you can figure out the coordinate the way it is right now, fine, just do the coordinate. But if you can't, change it to degrees. Can someone remind me from last week, what do you multiply by to change something from radians to degrees?
180 over pi.
180 over pi. So the pi's are gone, and we end up with 3 times 180. Or just think of 3 times 18, and then just put a 0. What's 3 times 180?
54.
54, and then just put a 0. So 540. Okay, so that's better. Okay, but now we're thinking about an angle that's 540 degrees. But to me, that's still kind of a hard number to work with. What could I do to this number to make it more manageable in my head? Just take away 360 from it. So 540, take away 360. Let's try it. 540, take away 360. 180. So what I'm really working with in this problem is a 180 degree angle. I need the coordinate for 180 degrees. Let's go back to our chart. What did we say earlier the coordinate is for 180? Yep, negative 1, 0. That's our x and that's our y in this problem. Negative 1, 0. Okay, so use this as your x, use that number as your y, and fill those numbers into this one. Now, you might be wondering, well, what would have happened if this number wasn't one of the 4 that we talked about so far? What if it wasn't 0, 90, 180, or 270? Well, that's not going to happen today. It's always going to be one of those 4. If you have to find the coordinate. One nice thing about this coordinate, it doesn't have any roots in it. So you're not going to have to worry about any square roots in the bottom and then having to fix it. That doesn't happen. All right, so let's start with sine. Kiana, what's our formula for sine? Y. And what's the y in this case? 0. That's it. Okay, the next one is cosine. Tony, what's our formula for cosine?
X.
Yep. And what's x in this case?
Negative 1.
Negative 1. And then tangent. Cameron, what's our formula for tangent? Yep. So it's y over x which means we need to do 0, that's y, over -1, that's x. And you need to tell me what that is, because I need to know, if you know, what it means to have 0 at the top of the fraction. What is 0 divided by any number?
0.
Yes. And for that problem, that's it. Now, let's say they did ask for the cotangent. That's the tangent flipped. So you'd have this. But what does it mean when you divide by 0? It can't be the same as this one. There's only two numbers you can flip and they stay the same, and it's 1 and -1. So what happens if you take 0 and flip it? What's -1 divided by 0? What? Nope. The only number you can flip to get 1 is 1. If you flip 1, you get 1.
You don't get an answer.
You don't get an answer. So what do we usually say when that happens?
Error.
That's what your calculator would say?
No,
We are humans.
Tell me.
Yep. Humans generally don't say error. Sometimes machines do.
No answer.
No answer, undefined. Yeah, we usually say undefined. So if they asked for the cotangent here, it's the tangent flipped. But you have to tell me what that would mean. When you try to divide by 0, it's undefined. You can't divide by 0. Why?
It just don't work like that.
Why don't it work like that?
Can't go to the beginning and decide that.
Somebody decided that?
Yeah.
So let's think of. Does everybody agree that is that correct? What I just wrote on the board?
100%.
100%. So the way you check it is you take this number times that number, and you need to get that. Is 3 times 2 6?
Yes.
So let's take 5 divided by 0, and let's say it equals something. We don't know. But to check it, you would take the number in the bottom times the number on the right, and it should give you the number on the top. So 0 times what gives you 5?
Nothing.
Nothing. That's why you can't divide by 0. Because 0 times anything will never be 5. And if you have a number and you divide by 0, it spells no. So you can't divide by 0. Any questions on those three? Okay. All right, let's look at this one. This time they want all 6. Find the 6 trig functions. But what are we missing to be able to do all 6? We're missing the coordinate. So you need to figure that out. What might we want to do with 11 pi over 2 as a first step?
Convert it.
Convert it to what?
Radian.
It already is radians.
Not that. Get it to the angle.
It already is an angle. Degrees. We want to change the units we're using. Okay, we want to change it to degrees. So to change it, multiply by 180 over pi. What's going to cancel there first? Pi's. And I can't cancel this, but I can reduce it. What reduces? The 180. How many times does 2 go into 180? How many? 9. Now you're left with 11 times 90. What's 11 times 90? 909. Okay, so better. I like that it's in degrees now, but that number is a little too big for me to think about because it's gone around more than one time. So what can we do to make that number smaller? Subtract.
7, 20.
What are you subtracting to get that?
360
Three-
twice.
360 twice, okay. So yeah, you could just subtract 720. Or if you didn't think of that, just take 990 minus 360. And then just hit it again. Minus 360. 270. Okay, so what we're working with this time is 270. So now, let's not go back to the diagram. Let's see if we can figure it out. Where's 270 on the circle? Yeah, it's on the bottom. And what's the coordinate when you go to the bottom, straight down? What is it? 0, -1. That's the coordinate for 270. Okay, let's fill them in and then see what we get. Remember, 0 in the top of a fraction, no problem, that's good. 0 in the bottom, can't do it. Okay, Sam, what's my sign?
Y.
Yep, and in this case, y is -1. Okay, Grady, what about my cosine?
That's X or 0.
X, which is 0. Good. Gavin, what's my formula for tangent?
Y over X.
Okay, so y is -1 and x is 0. So that's y over x. And what does that come out to?
No solution.
No solution. Yep, or we'll just write undefined. If you write no solution, that would be, you get credit for that. Okay, and now we're going to flip all of those to get to that last 3. What do you get when you flip -1? That's the other number you can flip and it stays the same. -1 stays as -1. So now we've got 0. If you're not sure, if you're like, wait a minute, that's not a fraction. Okay, then think of it like this. 0 over 1. What's going to happen when we flip 0 over 1?
It's going to be undefined.
It's going to be undefined. So if you flip 0, you get undefined. If you flip undefined, you get 0. And there's the 6 trig functions for 270 degrees, which is really 11 pi over 2. Same thing. Any questions on that? So that's the first part of unit circle trick. Tomorrow we'll look at coordinates that are 30, 60, and 45. Okay, so remember, homework, we are using a different book now. Okay, it's the trig book, but if you go to the homework assignment, the PDF file, it is the new book. Did anybody borrow a book from the pre-calc part of the class? Okay. Alright, so it's 11 to 27 odd and number 22. Okay, so you got just under 20 minutes or so. So you got a little bit of time to start that. I know a couple people need to check in with me, so I'll do that right now.